Okay, so there we go. So we know exactly who's going to gain and who's going to lose. But we also now know how many they will gain, but also how many they will lose, right? And so, in terms of electronegativity, electronegativity will dictate what happens here from here on out in terms of bonding, but also in terms of again, who's going to lose and who's going to gain, and how many they're going to lose and how many they're going to gain, right? And so, can we tell who's going to lose and who's going to gain? Yeah, right. And so, like we said, the alkali metals, the alkali earth metals, and the transition metals, these metals over here, they will all lose, right? And then therefore take on a plus charge, right? Whereas the non-metals over here, so the non-metals, right? These will all lose electrons and take on, these will all gain electrons. Sorry, these will all gain electrons and take on a negative charge, right? And so we can tell who's going to gain and who's going to lose just based upon understanding electronegativity. Right, and so electronegativity will dictate what happens with these elements. And so again, we can see that the alkali metals. So the alkali metals here will take on a +1 charge. They will all take on a +1 charge. Why? And so why they're all in the same group, or all in the same family, and they will all do the same thing because they all have the same valence shell structure. So they all have one valence shell electron, and as a result of that, they will all do the same thing, which is lose one valence shell electron, right? And so whereas the alkali earth metals, these have two valence shell electrons, and so as a result of having two valence shell electrons, they will all lose two valence shell electrons and take on a +2 charge. Whereas the transition metals, they take on multiple oxidation states because of the fact they lose multiple different electrons. Okay, and so for example, iron can be a +2, +3, even +4 charge, right? But this is that iron that we need in hemoglobin. We talked about hemoglobin. We talked about how the oxygen binds to the hemoglobin, and we need that. Right, but we can tell the difference between an arterial bleed and a venous bleed. Right, when we have oxidized iron, just like in the environment, it turns kind of a brighter color. So we can tell the difference between bright red blood or bright red blood per rectum, for example, and so maybe a lower GI bleed, right, or like colon cancer, for example, versus say an upper GI bleed. Right, and so when you lose a lot of that oxygen within the within the red blood cells, it turns more of a darker color. And so if you have dark stool, that may be indicative of an upper GI bleed, right? Or more of a chronic bleed, right? And so these are the things that you're going to be thinking about and learning about, certainly in nursing school. And it's directly related to, again, electronegativity, basic chemistry, right? And so again, you'll love to learn chemistry and understand how chemistry works, right? And so when we talk about all of the wires in your home and all of the electronics in your home, these are all copper wires, right? And so they're good conductors of electricity. But so is silver and also gold, right? But also some of the other elements around here either. And so also, I should say. And so when you talk about a lot of these smartphones and a lot of these very expensive devices, right? Well, they're using a lot of these precious metals for their ability to process electricity and process energy, semiconductors and things like that, right? And so they're able to really do these things quickly, right? And so again, this is all a part of life. Okay, and so group 13 here takes on a +3 charge, group 14 ±4 charge, group 15 a -3, group 16 a -2, and group 17 a -1 charge. And again, the halogens, the halogens are very reactive, and so the fluorine, chlorine, bromine, iodine, astatine, they're very reactive, and so that's why we use them to kill things. And so again, that betadine in surgery, right? That Clorox bleach that you use to clean the toilets and the bathrooms with, right? And the calcium fluoride that you brush your teeth with. Again, so these are components of life, right? And so you'll definitely see see these same concepts. Okay, all right. We'll go ahead and conclude here.